This video will demonstrate how to find the pH of a weak acid or weak base. In this specific case, we're going to be using acetic acid. Rather than write out the complete formula for the acetate ion, I'm using shorthand AC. And so we have the overall reaction, the initial concentration, and a Ka. So we have to write out our ice table for the initial concentration, the change in concentration, and what that concentration will be when we're at equilibrium. So the initial concentration is 0.1 molar. We have no common ions to worry about. Everything is 1-to-1, so we will lose an amount here and gain the corresponding amounts here and here. Equilibrium is the sum of those first two lines. So we have 0.100 minus x, and x. And now we substitute into our Ka expression. So Ka is 1.78 times 10 to the minus 5. This will be equal to the product of these two concentrations. So that's x and x divided by our reactant concentration. Now, the approximation method says that we'll see what happens if we assume that the amount used up is very small relative to the initial amount. That means then that we can write that the Ka is going to be equal to x squared divided by 0.1. And so that's just 1 times 10 to the negative 1. So what we'll have is that 1.78 times 10 to the negative 6 is equal to x squared. Once we take the square root, we'll find that this gives us 1.33 times 10 to the negative third equals x. And all we have to do then is check the 5% rule. So if this amount that we found using the approximation method is less than 5% of the initial, we're good to go. 1.33 times 10 to the negative third divided by the initial amount, which is 1 times 10 to the negative 1. And this gives us a value of 0.0133, which is 1.33%. So this is less than 5%, so that's a pass. And we can use this value for x after all. So because x is the hydrogen ion concentration, we now know that quantity. And to find the pH, we have to take the negative log of this. And that gives us a pH value of 2.88. So because the approximation method result passed the 5% rule, we're able to stop here with the concentration and pH value.